Okay, so here is chapter 5 of our rational expressions notes. Here's where we are going to continue on with graphing like we did last time, except now we're going to encounter some holes in the middle of the graph. So think of this as kind of like a review from chapter 4, except now we're going to add a little bit of something extra to it. But not too much. The part we're going to add on is really not going to be overly complicated. So first things we need to do, we've got an expression like this, and we need to factor what's on the bottom. So if we do this, the top stays the same. If we factor the bottom, we get x plus 2, x minus 3. So you'll notice here we can cancel out the x plus 2. Not too bad. We get 1 over x minus 3. So here's our expression. This is what we're going to graph. Now notice, remember last time what we did is we took a original function like this, graphed that, and then graphed the reciprocal of it. So we are going to do the same thing here. What I'm going to do is I'm going to take the x minus 3, I'm going to graph that. So here's my y-intercept down here at negative 3. My slope is 1, so I'm going to get a graph that looks like this. If I do this properly. So here is my, whoop, I completely missed the dot. Sorry about that. Wait, what am I doing wrong? Goes from here. There we go. That's the right one. Should be this one. Sorry, ignore that. Ignore this other graph, other line. So here's the original. This one is going to be my y equals x minus 3. This is the denominator. And I just did this so you can get a feel for what this should look like. From here, I'm going to put the asymptote. Remember, the asymptote is just where this line touches the x-axis. So here is my asymptote, like this. And then I had showed you last time that what you need to do is take some points on either side of the asymptote and see what the graph looks like. I also showed you this little shortcut where you can imagine that with my asymptote here and with the x-axis, I've got some quadrants. So I've got this quadrant up top, this quadrant down here, this quadrant over here, this quadrant up here. And from that, knowing this function is up here in this quadrant and down here, that my function needs to look something like this. Again, if this part doesn't make sense about the shortcut, don't worry about that. We're just going to put it in here. You can still use the table of values. Pick x equals 4, 5, 6. Pick x equals 0, 1, 2. And see what numbers you get. And then you'll get a graph like this. You can still do that if you want. Now the problem with this is I actually have some other restrictions in here. If I look at my original function, what are my restrictions for this? So I've got that x cannot equal 3, and I have x cannot equal negative 2. I've got two restrictions. My asymptote is at x equals 3, but what happens at x equals negative 2? So if I look at this, where is my negative 2? So it's way over here. So if I continue this graph, it's going to keep going closer and closer to the x-axis. At x equals negative 2, so over here, there's going to be a hole. So this is what happens with your restriction. And you'll notice as you go through this, this is what happens every time you cancel out one of these restrictions, or if something on the denominator is canceled out. Instead of getting an asymptote, you just end up with a hole. And that's basically the gist of what we're doing today, is just something like that. Again, just kind of to review the process, what we did here. So I graphed, if I have 1 over something, I graph the denominator, take a look at what that looks like, get my asymptote wherever it crosses the x-axis, and then plot out my graph, the inverse part of that, and then check to see what my restrictions are and make sure I've covered both of those. So I covered x cannot equal 3, there's an asymptote, and I covered x cannot equal -2 with the whole. So that's what you're going to do. Let's try a different example here. Let's try this one. So again, let's factor this and actually simplify what this expression is. So I've got x minus 3, x plus 2 on top, x plus 2 on the bottom, the x plus 2's cancel, and I'm left with x minus 3. So this one's easier. I don't have a reciprocal to deal with, I just have x minus 3. So I can plot this one out just like I did in the other one. But before I plot this, let's look at restrictions. So I have that x cannot equal -2. Again, that just comes from making sure the denominator can't equal 0. So I need to plot this graph, but where x equals -2, I'm going to put a circle. So let's draw this. -1, 2, 3. There's my y-intercept here, and let's make sure that I actually graph this properly this time. So going up by 1s, going like this. So here's my line, and I'm going to check where's -2, so there's -1. I'm going to leave a spot here at x equals -2, and I'm going to put a circle. So instead of actually equaling what's at that point, I put a hole here. So this is wherever you've got that, you cancel out whatever the restriction is, and the bottom, you're going to get a hole. Let's try another example here. Let's try D, because this one will give us what we want. Good example. So for this, I need to factor out the bottom. So I've got 3 minus x on the top. I've got x minus 3. I feel like it keeps being the exact same equation. So I got this. And up at the top, what I can do is I can flip the signs of both of these and end up with a -1 and a positive x minus 3. This way I can cancel out one of the denominators here. Oops, sorry, you can't see that. There you go. So factored out the -1, I've got x minus 3 on the top and the bottom, cancel those out. I've got -1 over x plus 2. So in order to do this, remember we wanted to graph out what the bottom number is. But notice I've got a negative at the top. So what I want to do is I want to distribute the negative into the bottom here. So 1 over -x minus 2, so that I can actually plot out this bottom number. And I want to figure out how this works. So I have this. Let's look at restrictions here before we start graphing. So x cannot equal 3 and -2. Again, that just comes from what makes the bottom number 0. And here we go. Let's plot this out. So I'm going to plot out x, -x minus 2. So minus 2 becomes my y-intercept, and my slope is -1. So I'm going to go through like this, plot out my slope. I'm trying to make this as precise as possible. There we go. So this is y equals -x minus 2. That's not the graph that I want. This is just the reciprocal of this. Or sorry, this is just the denominator. I want to plot the reciprocal of this. Again, what I need to do is look at where is my asymptote in this graph. It's at the x-intercept, which is here at -2. Plot this out. Again, look at the different quadrants. So here's my top left quadrant. I'm in that quadrant. So therefore, I'm going to have a graph that looks like this. It should be a straight line here. I didn't draw it all that great. And I'm also going to be involved in this quadrant bottom right. So I will have some sort of function that goes like this. And I need to take a look at the restriction. I didn't deal with the restriction. I dealt with -2, there's an asymptote, but the x minus 3 got canceled. So at x equals 3, 1, 2, 3, I need to put a hole. If you do something like this and you drew the line in the middle, I'm going to be okay with that. Just make sure you put the circle there to indicate that there's a hole in that spot. So that's the essence of chapter 5. So I flip over to the next page here. You just get a few more complicated expressions with this. So you get some more holes that are going to be in here. But the gist of this is going to be the exact same. I'm not going to spend more time on this. I'd rather answer questions in class, and you have less videos to watch for this. So that is chapter 5. Again, here's your process. I'll show it with this one. So the process is first simplify your equation. So factor it out, simplify it till you get some expression. Graph if you have a denominator. If you don't have a denominator, like you did here, just graph it normally. But if you have a denominator, graph out that. Once you've graphed out this original line, find the asymptote, and then plot the reciprocal. And to do that, you just look at which of the quadrants, the 4 quadrants around your the asymptote and the x-axis that you have. And then look for holes. So make sure you look at the restriction. Where are the holes? So there's chapter 5.